Hello and welcome to this video on writing chemical equations. So just a brief overview about equations. We know that equations are something that represent the actual chemical reaction that take place. And so we have on the left-hand side our reactants, on the right-hand side our products, and then we use this arrow to represent the change from left to right. We also oftentimes are going to represent what state of matter any of our compounds or molecules might be in. And so solid, liquid, gas, they're just the lowercase for the first letter. And then for aqueous, we actually use AQ. And I know my Q's always look a little strange, but that is a Q. And that just means that it's been dissolved in water. We must make sure that we're showing that matter is conserved by having the same amount of each element on both sides, and we do that by using a coefficient or a large number before the compound. We cannot change just the formulas of our compounds and molecules with the subscripts. We have to actually use the superscript, and then we multiply that through our element in order to be able to balance these. So another thing we have to keep in mind as we work through these is we have some diatomic molecules. And so these are molecules that when they are found in nature by themselves, not in some other sort of compound or molecule, they're found to be two of them bonded to each other. So H2 is an example, and then if we start at number 7, which is nitrogen, and we make a 7, okay, so all of these ones here that I am boxing in, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, those are all in addition going to be diatomic molecules. So if it says oxygen, then we know it's always going to be O2. Okay, and so we're going to see a couple of these in our examples today, and that's just something to keep in mind. So our first example is going to be what happens when water is separated to form hydrogen and oxygen. And so this is actually a chemical process that we can do. And so we're going to start with water. Whatever we start with is generally tends to be our reactants, and so water, H2O, and it doesn't say this explicitly, but at room temperature water should be a liquid. And then where it says separated, that is telling us that there's a change from one side to the other. So that's going to be our arrow. And then on the other side of the equation, it says that we're going to form hydrogen and oxygen. Now remember, these are diatomic molecules, and so it should be H2, and that's going to be a gas, plus O2, which is also going to be a gas. And you may not know that by itself, but I'm trying to give indicators in most of these, but H2 and O2 are a gas at room temperature. So now let's go ahead and balance this equation. And so we can tally on each side. We have 2 hydrogens and 1 oxygen on the left-hand side, and then on the right-hand side we have 2 of each. So now what we have to do is use that coefficient in front, and so in order to get 2 oxygens on each side, we have to put a 2 in front of water. Now that changed to give us 2 oxygens, but it also changed the number of hydrogens that we have. And so now if we have 2 H2O, so if we have H2O, let me do this up top, H2O plus H2O representing 2 H2O molecules, how many total hydrogens do we have? Well, we would have 4 hydrogens, so 2 plus 2 would give us 4. So that gives us 4 hydrogens. That means on the right-hand side of the equation, we have to go back and add a 2 in front of hydrogen, and that'll give us 4, and that is a balanced chemical equation. Let's try another one. So here we have solid lithium metal. Okay, so we're going to have lithium as a solid. And chlorine gas. Chlorine is going to be a diatomic molecule, so plus Cl2, and that's a gas, and they are going to react. So as soon as we see the react, we know that's where our arrow goes. There's a few different indication words that kind of show us the change between each side. So that is going to be the one for this one. And then it says to form solid lithium chloride. Now so lithium chloride is an ionic compound because we have a metal and a nonmetal. And so we have to go back to our formulas. And so we know lithium is a +1 charge and chlorine is a -1 charge. If we crisscross those, they're also in a 1-to-1 ratio already. And so we get lithium chloride, LiCl. And that is a solid. Okay. Now I think we can go ahead and balance this equation without having to tally everything up. We have 2 chlorines on the left-hand side, so we need to put a 2 in front of lithium chloride on the right-hand side, and then to balance the lithium, we're going to put a 2 in front of lithium, and that is a balanced chemical equation. Let's try one more. So in this last one, we are going to have lead nitrate, lead 2 nitrate. So when we have lead 2, that gives us Pb2 plus. Nitrate is an NO3 1 minus charge. And so when I use my crisscross method, I get PbNO3 2. So PbNO3 2, and that is aqueous, AQ, plus I have aqueous sodium chloride, so NaCl, and they are going to react, so here's our arrow again, to form aqueous sodium nitrate, so NaNO3, it's a +1 charge and a -1 charge, so we can go ahead and easily write that out. And then solid lead chloride, so this is a precipitate reaction, plus, and that's going to be Pb is still the 2 plus ion, it doesn't change, so PbCl2, and that is a solid. Okay, and so once we have that written out, then we can go ahead and go back and balance our equation. And so if we put a 2 in front of sodium nitrate and a 2 in front of sodium chloride, we have a balanced chemical equation. I hope that's helpful for you.